Hello everyone, a very warm welcome to this introductory lecture for the course ME22088 Vibration and Noise Control. I am Dr. Sendamarai Kannan, Associate Professor in the Department of Mechanical Engineering at SVC. I am delighted to be your instructor for this course and I am looking forward to exploring the fascinating world of vibration and noise control with you all. Now, let's move on to the core content of our course. We'll begin with Unit 1, which focuses on the fundamental principles of vibrations. In this unit, we will lay the groundwork for understanding the behavior of vibration systems. We will start with an introduction to the concept of vibration, exploring its various sources and the different types of vibration that can occur. We will also delve into concept of damping and its different forms. A significant portion of this unit will be dedicated to analyze single degree of freedom systems, both with and without damping. These are the simplest forms of vibrating systems. Understanding them is crucial for tackling more complex scenarios later on. Finally, we will learn how to determine natural frequency of this single degree of freedom systems, which is a fundamental parameter in vibration analysis. As you can see from these illustrations here, we will be looking at various examples like simple spring mass systems, torsional pendulums, and even mechanisms that can exhibit vibrations. This unit will provide you with the essential building blocks to understand and analyze more intricate vibration problems in the subsequent units. Moving on to Unit 2, we will now step up the complexity and explore systems with 2 degree of freedom systems. In the previous unit, we focused on systems where the motion could be described by a single coordinates. However, many real-world systems require more than one coordinate to fully capture their vibratory behavior. In this unit, we will first examine the free vibration of these 2 degree of freedom systems and learn how to determine their natural frequencies. Unlike single degree of freedom systems, which have only one natural frequency, these systems will exhibit multiple natural frequencies and corresponding modes of vibration. We will then delve into concept of forced vibration in these systems, and specifically we will study the phenomena of transmissibility, which describes how vibrations are transmitted through a system. This leads us to the important topic of vibration isolation. We will explore various vibration isolation methods and learn how to design systems to minimize the transmission of unwanted vibrations. Finally, we will introduce a very practical application of 2 degree of freedom systems, the dynamic vibration absorbers. This is a very clever mechanism used to reduce or eliminate vibrations at a specific frequency in a primary system. The illustrations on these slides revisit some examples of 2 degree of freedom systems, forced vibration systems, and transmissibility systems. In Unit 3, we will extend our understanding to systems with multiple degree of freedoms. Building upon the concept of single and 2 degree of freedom systems, we will now explore systems where the motion requires more than 2 independent coordinates to describe. These types of systems are much more representative of real-world engineering structures and machines. We will begin by understanding the concept of influence coefficient, stiffness coefficients, which are very much crucial for formulating the equations for multi-degree of freedom systems. We will then delve into mathematical tools needed to analyze these systems, specifically focusing on the determination of eigenvalues and eigenvectors. These mathematical entities provide critical information about the system's natural frequencies and mode shapes. We will also learn how to represent systems properties using flexibility matrix and the stiffness matrix, which are very powerful and important tools for complex analysis. Furthermore, we will explore matrix iteration method, a numerical techniques used to find natural frequencies and mode shapes of these multi-degree freedom systems. Finally, we will see some important approximate methods like Dunkerley's method, Rayleigh's method, Olser method, which provide efficient way to estimate natural frequency of these systems. The illustration on this slide show examples of multi-degree freedom systems like multi-story building frame, which can vibrate in multiple ways, and a beam with several masses attached, representing a system with multiple degrees of freedom. This unit will equip you with the skills to analyze dynamic behavior of more complex engineering systems. Welcome to Unit 4, Engineering Noise and its Control. In our modern world, we are constantly surrounded by sounds. While some sounds are pleasant or necessary, unwanted sound or noise can have significant negative impacts on our health, well-being and productivity. This unit delves into the fascinating world of engineering noise, exploring how it is generated, how it propagates, and most importantly, how we can effectively control it. As you can see in these images, we will be looking at various aspects of sounds. We will start by defining fundamental concepts like sound power, intensity, pressure levels, and learn how to quantify sound using in the form of decibel scale and sound spectra. We will also explore how different weighing networks and equivalent sound levels help us understand human perception of loudness. We will then examine the effect of noise, relevant ratings, and the regulations in place to manage it. Understanding the source of noise is crucial, so we will identify common industrial noise sources and explore various isolation and control strategies. These strategies include addressing noise at source, along its path of propagation, as illustrated by sound barriers in this image, and at the receiver. So get ready to tune in and learn how engineering principles can be applied to create quieter and healthier environments for everyone. Welcome to Unit 5, Measurements and Control of Vibrations. Just like unwanted sound, excessive or uncontrolled vibrations can lead to a multitude of problems in engineering systems, ranging from discomfort and fatigue to equipment failure and structural damage. In this unit, we will explore the fascinating world of mechanical vibrations, focusing on we measure the system and its techniques to keep them under the control. As you can see from the slide, we will begin by examining various vibration measuring devices, including different types of transducers and vibration pickups. We will also delve into vibration exciters such as mechanical and hydraulic types, which are used to induce controlled vibrations for testing and analysis. Understanding the frequency content of vibrations is very much crucial. So, we will explore frequency measuring instruments like single read, multi-read and stroboscopes. We will then touch upon more advanced techniques like experimental model analysis, use of powerful tools like FFT analysis to understand the dynamic characteristics of the structures. Finally, we will focus on vibration control methods and its devices. This includes learning about isolators, absorbers and balancing techniques. All are essential for mitigating the harmful effects of vibrations in various engineering applications. So, let's get ready to delve into the world of vibrations and learn how to effectively measure and control them. Thank you for your time and attention. I hope you find the information presented here are valuable and insightful. If you have any questions, please don't hesitate to ask. We appreciate your engagement and look forward to continuing our learning journey together. Thank you once again and one and all.